Okay, welcome to the Unit 5A Lesson 2, Multiplying and Dividing Radical Expressions. All right, the learning objectives for this video is to be able to simplify radical expressions with indexes of 2, 3, or 4, and actually we're going to look at a fifth root as well. So we're also going to look at multiplying and dividing to simplify radical expressions with the same index, and we're actually going to look at sometimes when the indexes are different. All right. Sometimes it'll be the same, sometimes it'll be different. So let's take a look at what we're going on here. We've worked some with rational exponents. We've done some simplifications of radicals. So let's this is going to be an attempt to try to simplify things and just practice a little bit with some more complicated problems. So when I look at this, we're negative 4 to the third power. That's going to give me negative 64. Understanding that those two things are the same, when I'm looking at a radical problem here, right? Oh, I have a negative 64. I can change that so that now I'm looking at the third root of negative 4 to the third power, right? Just like addition and subtraction are inverse operations, multiplication and division are inverse operations, powers and indexes, powers and roots are inverse operations in much the same way. So the third root of negative 4 to the third power is just simply negative 4, right? That root and that power will undo each other, okay? Now, if the index is odd, then the root will always be the same sign. As the radicand, right? And the radicand is just the number under the radical symbol, okay? So i.e. negative 64. Negative 64 is the radicand. Okay, just to give you a little bit of terminology. All right, so if we're looking at that, that's the radicand. If that's negative, then the answer will be negative. All right, pretty straightforward. Another one we want you to be able to understand is that 3 to the fourth power is 81. So if I'm looking at the fourth root of 81, I'm thinking, oh, the fourth root of 3 to the fourth power. Okay, well, those are going to undo each other. So I'm going to get 3. Okay, so all pretty straightforward. If you get a number under a radical symbol, it's going to help you to basically break it down into a base with an exponent, the smallest base you can get with the exponent. Right? So try to simplify the number before you start messing around with it. All right? Now, a couple rules here. If you have an even index, right? If n is even, right? If the index is even, and that's the 4 here, that's an even number. The radicand, which we're talking about here, is 81 in this case. It's positive. So we're only going to care about the positive solution, or the positive root, right? And that's also known as the principal root. Yes, we know when we had equations, we talked about positive, negative, the plus, minus. We always talked about we wanting both of them when we're solving an equation. But this is not an equation, right? There's no variable equal to something. So we don't care about the negative. We only care about the positive, all right? When we're simplifying, we only care about the positive root, all right? Now, what happens if the radicand is negative? What if I had a negative 81, right? Well, if it's a square root, you know that's going to be imaginary. If it's a fourth root, it's going to be imaginary. If it's a sixth root, it's going to be imaginary. Anytime that index is even and the radicand is negative, there are no real solutions. Okay, so if we give you a number that's negative underneath the radical sign and the index is even, you will tell us no real solution, right? Except for this one case, in problems like this, where you see that the index and the power are exactly the same. So this is only true when index and power are equal, right? Now if it's odd, it doesn't matter, right? Because odds are always going to be the same sign. So you can say always same sign, right? Doesn't matter. It's always the same sign. It's negative. It's the square root, the cube root of -8, right? Cube root of -8 would be -2. The cube root of +8 will be +2, right? Here's where it gets interesting, is when we have a even one, all right? So if I had the fourth root of -2 to the fourth power, right? We could kind of do an order of operations kind of thing to help you understand why this works. -2 to the fourth power is 16. So the fourth root of 16 is +2, right? If I'm looking at the fourth root of 2 to the fourth power, again, 2 to the fourth power is +16. So the fourth root of +16 is 2. So, again, when these two numbers are exactly the same and you have a negative radicand, you can actually cancel these out, but the result will always be positive, right? Always positive. If the index and the power are exactly the same, your answer will be always positive, okay? So kind of keep that in mind, but it won't come up too often. All right, so let's look at some practice problems, all right? Last class, when we were reducing radicals, we always gave you numbers that were nice. They always broke down to a nice number on the outside with nothing left under the radical symbol. Well, this class, we're going to step it up a level, and we're going to break these numbers down into smaller numbers, and sometimes there's going to be stuff left over. And we'll show you what to do with those. So, the first thing I want to talk about is this rule up here that says that if the index is odd, my answer will always be the same. So, this is an odd index. This is a negative number. So my answer is going to be negative. So I'm just going to bring that out now. And also the thing that I also want to re-emphasize is if you're doing a radical symbol, always write your index right after you do the symbol. Otherwise, you may forget it, and then you're going to lose points because you forgot to write your index. So I always write my radical symbol, then write my index, and then start putting stuff in. So 54, let's see, what is 54? I see 9 times 6. Well, 9 is 3 times 3, and 6 is 3 times 2. So I can write 54 as 3 to the third power times 2 to the first power, right? Because I have 1, 2, 3 3s, right? And I have 1, 2. So I can rewrite that. And now, using our properties, I now have negative third root of 3 to the third power times the third root of 2, right? There's only one negative sign, so there's only one negative sign, all right? This, we know, cancels out, so that gives me -3. And then we'll have this third root of 2 left over, okay? And that's basically what you're going to be doing, right? Break these numbers down with prime factorization, right? This is a prime factor tree. So that's what we want you to do. And then we're going to work through these problems. So give it a try without variables. Pause the video, give it a try, and then restart the video and check it out. Okay, so here's your solutions for number 1, number 2, and number 3. If you have any questions about that or don't know why I got the answer that I got, ask a question in class next time we see you. Okay, so now let's take a look at what happens when we have numbers and variables together. Okay, so you're going to think about this as kind of three separate things, but again, I want you to kind of stretch this out and break this down. Now, 32, right? What is that? That is 8 times 4, which is 4, and 2, which is 2 and 2, and this is 2 and 2, right? So eventually you should be able to get to a point where you look at 32 and you just know, oh, that's 2 to the 5th power, right? So this is 2 to the 5th power, x to the 4th, y to the 7th, all right? Now, I'm going to further stretch this apart because I want to be able to cancel out that third root. So if I'm thinking about this, I'm going to break 2 to the 5th into 2 to the 3rd times 2 squared. X to the 4th gets broken into x to the 3rd times x to the 1st. And y to the 7th, I'm going to break into y to the 6th times y to the 1st. Now you may be asking me, well, why didn't you do y3? Well, because I have y6 is 2 y3s. You could think of it as y squared to the 3rd power, right? And then that way that'll cancel out. I'm left with a y squared. Another way to think about it is this is a fraction, right? 6 divided by 3 will give me y squared. So let's take a look at this, all right? So these will cancel out, right? So that gives me a 2, and I've used this, so that's gone. We're going to skip that one. X to the 3rd will give me an x, and I've used it, so it's gone. Skip that one. Y to the 6th, so 6 divided by 3, as I said before, is y squared, and now that's gone, right? So I simplified those three, and now here's my radical, there's my index. What's left? 2 squared, which is 4, x, y. And there is my problem simplified. Okay? So, pause the video, try these next two problems, and then come back and I'll show you the answer. All right? Okay. So, here's the solutions for number 4 and number 5. Again, 64 is always 2 to the 6th, so I just jump 2 to the 6th, and it's 2 to the 6th over here. But how I break it up was different, right? I did 4 and 2 here, 5 and 1 here, all depending on what my index was, right? So that index is going to tell you how to stretch it apart, how to break it apart, all right? Let's go over to, this should be kind of a little bit of a review, right? We've done square roots times square roots where you just multiply them. Well, that rule applies no matter what the index is. If the indexes are the same, so we have nth root and nth root, when they're being multiplied together, it's just going to be the nth root of a times b. Okay? The same thing with division, right? If the indexes are the same and they're both real numbers, that's an important part. To be able to do this, you have to have real numbers to start with. You can just turn that into one big problem where it's a divided by b. And then just do the division or do the multiplication, right? Now, when we look at this as an example problem, I always kind of like to think strategically here, right? If I'm looking at this problem, I see, let's kind of put it all together, but I'm not actually going to multiply the 4 times 2 because that's just going to make my number bigger. Why not just consider the third root of negative and then 2 times 2 times 2, right? Because 4 is 2 times 2, and there's another 2. And then I have x to the 9th, and then y to the 3rd, right? So that gets me, let's bring that negative out, because there's only 1. And then that's 2 to the 3rd power, x to the 9th, y to the 3rd. So negative 2 x cubed y, and there's my problem solved. Okay? Kind of straightforward. Shouldn't be too bad. let's look at this one, right? Let's simplify, right? Negative 64 x to the 5th over 4 x to the 4th. Negative divided by positive. Let's do our index. So that's negative 16. Subtract those, I end up with x. Well, 16 is 2 to the 4th power, so I'm left with negative 3rd root 2 to the 4th x, so that's negative 2 3rd root of 2x. And there's our simplification with division, right? Just go ahead and divide the numbers if you can. That makes them smaller. Here you can multiply them together, you get 8. Know that 8 is just 2 to the 3rd. But again, sometimes I think with numbers, it's easier to make them smaller first before you make them bigger. All right? So pause the video and try number 6 and try number 7. Okay, so here's our solutions for number 6 and number 7. So check those out. See if you have any questions about those. Come talk to us. But I showed you the work. It should kind of make sense. I tried to show us the steps as broken down as I could, but if you need help with that, let us know. Nope, not the different page, but just down here at the bottom of the page, right? We're now going to think about what happens with our indexes are different, right? And this actually should be an A here, right? So here our indexes are different, right? We have an N and a Q. Those are different from each other. So that's where rational exponents come into play. I can switch this to a to the 1 over 9th, or 1 over n, times a to the 1 over q. Now because I can do that, right, my base is the same, so I'm just going to add these two together. And that's just the property of exponents, right? So what happens when I divide, right? What if it's the nth root of a divided by the q root of a, right? Where my indexes are different. So you can't just make that one big thing. But what is division? Division is subtraction. So a to the 1 over n divided by a to the 1 over q. Well, I subtract those, so I end up with a to the 1 over n minus 1 over q. So switch the radicals into rational exponents and then apply the exponent rules to apply. Now, the key here is that these have to be real to begin with. If the radical is not real, then you cannot switch it to a rational exponent. These all rely on the radicals being real first before you switch it into rational exponents. And so it gets a little tricky when you see some problems that you think you should be able to do, but remember, always check to make sure they're real first. That's the number one rule to apply first. All right, let's look at some examples. So 7 to the 1/3 times 7 to the 1/4, right? So 7 to the 1/3 plus 1/4. Well, this is just adding fractions with unlike denominators. So 1/3 becomes 3 over 12 plus, sorry, that's 4 over 12 plus 3 over 12. So I get 7 to the 7 over 12. All right, make sure you understand how to add fractions when the denominators are different, or you're going to have trouble with this unit. All right, so the second example looks a little complicated because 2 and 32 are not the same base, right? They're not the same radicands. So how could I possibly do this problem? Well, let's change that number into a base 2. So 3 third root of 2 times, that's 2 to the 5th. So we're looking at the 4th root of 2 to the 5th power. So now I can do 2 to the 1/3 times 2 to the 5 over 4, which gives me 2 to the 1/3 plus 5/4. So what is that going to give me? 1/3 plus 5 over 4 gives me 4 over 12 plus 15 over 12. So my answer is 2 to the 19 over 12 power. Not a very pretty number, but it is what it is. All right, so division. Division's a little tricky because we are doing subtraction, and this example shows us what's happening when we end up with more on the bottom, right? I have 1/3, 1 over 4x to the 1/3, right? We can't have fractions on the denominator, right? No fractions in the denominator, right? So I need to get that up to the next whole number, which would be 3 over 3. So I can do, right, if this is my problem, I'm going to multiply by x 2 over 3 on top and bottom, because I'd add these exponents and I would get 4 times x to the first power over x to the 2/3. So I've just rationalized my denominator. In this case, we're just going to stick with that, right? I have a whole number in the bottom and a proper fraction in the numerator, so we'll leave it at that, all right? And we'll practice this in class. If you have questions, we'll talk about it. But this is kind of the next step up, a little bit harder problems, but nothing too new, I hope. And if you have any questions, we'll talk about it in class.